Okay, let's look at each of these. So this was question 21, and we have log base 3 on both of these. And then also notice that it's a plus. So reminder that when you have two logs that have the same base and they're added together, then that's the same. So I keep that log base 3, but now we can take what's in here and what's in there and we can multiply them. We can do x times by x minus 6. So when items are multiplied and it's that log base 3, it could be separated like this or it can be combined. Okay? So because it's an addition, that's why we multiplied. Remember that when it's a subtraction, that's when we divide. Okay, this equals 3. Great. Now, we're going to change this into its other form. And remember how we started with the base? So we said, okay, here is that base 3. And then what was in the parentheses and what was on the other side of the equal sign, we switched those. So then because this was on the other side of the equal sign, it became the exponent to the base. And then it's going to equal this x times by x minus 6. Okay. Now, let's distribute this, and then same here. When we're looking at this, the 3 cubed was 27, and then we get x squared minus 6x, because I distribute the x here and then here. All right, now this was the part that I was missing. We're going to subtract 27 to the other side. So it's going to be 0 is equal to x squared minus 6x minus 27. Now this is an exponential that we can factor. We can turn this into, now it's an x squared, so I'll put an x here and I'll put an x here. And remember, we need two values that multiply to give me negative 27, and then they have to add to give us 6. Negative 6. Okay, so multiply to 27, add to negative 6. All right, so let's think about this 27. So yeah, 1 and 27, 27 doesn't divide by 2 evenly. But we could do 27 divided by 3, because if you do 3 and you multiply it by 9, then it's 27. But if we want this to be a negative 27, we need one of these to be a negative, and we need them to add to be negative 6. So what if we make the 9 negative? Because we could do this. Negative 9 plus 3 would give us a negative 6. All right, great. Now we're going to solve for x for both of these. So we have 0 is equal to x minus 9, and we have 0 is equal to x plus 3. So then if you rearrange where we add the negative 9, we have x is equal to 9, and then we have x is equal to negative 3. Okay. Now I want us to double check this, but I was seeing that for these logs that we can't have x as a negative value. And so then I believe that our only answer option is that positive 9, that we can't put the negative in there. And I mean, let's check this. So we can do, here's my log base 3, and let's check if this negative 3 works or not. So negative 3 plus log base 3, and then negative 3 minus 6. And if this value works, it should equal 3. But domain error, yep, it doesn't work. We can change the x value to be the other one, which was 9. So it can be 9, and then we can also plug in the other x as a 9. And oops. Let's see. I think I just put one too many parentheses maybe. Yeah. And yeah, see how that does equal 3. So then that is a valid answer. So I would walk through that, and that's how we know that x is equal to 9. So one last time. When it's two logs that have the same base and they're added together, we can take what's in the parentheses and multiply them together. Then we have that same log with the same base. X, what I'm solving for, was in the parentheses, so I want to move it out of the parentheses. So I took the base, and then I flip-flopped what was in the parentheses and what was on the other side of the equal sign. So what was on the other side of the equal sign became the exponent, and then what was in the parentheses went on the other side of the equal sign. We then distributed the x, so this became x squared minus 6x, and I did my 3 cubed, I got 27. I subtracted 27, and this gave me an exponential that we could factor. And so we factored that as x minus 9, x plus 3. And so then you set those both equal to 0, and you solve for x, or it's the opposite of what's in the parentheses. It's a positive 9, it's a negative 3. And I don't think we can have negative values with these logs here. I don't think x can be a negative value inside the log. But we double-checked our work by plugging it into the calculator, and yes, this answer did validate. That one did work. Okay, so let's try this next one. If you want, you can pause the video and try it yourself first, and then press play and see how you do with 22. Okay, this one I'm guessing is going to be similar because look, we have log base 2, log base 2. It's added together, so that means when they're added, we can multiply what's in the parentheses. So this would be x multiplied by this one, which is x minus 6 again. Oh, this problem's really similar. It's just a base 2 instead of a base 3. Okay. Great. And that equals 4. All right. So we're going to do what we did last time, which we're going to take the base, bring that down, and then we're going to flip-flop what was on the equal sign and what was in the parentheses. So the other side of the equal sign becomes the exponent, and this is going to equal what was in the parentheses. Let's distribute the x, and then 2 raised to the 4th is 16. So 16 x squared minus 6x. Okay. Let's subtract 16. So we have 0 is equal to x squared minus 6x minus 16. We need two values that multiply to negative 16 and add to negative 6. Okay, what about this? 8 and 2. Now one of them needs to be negative because I need them to add together to be negative 6. But if we make the 8 the negative, so negative 8 plus 2. Those would add together to give me my negative 6. All right. It's equal to 0. And so then we could add the 8 to the other side. We could subtract the minus 2. Just like we were doing before, we'll have an x is equal to 8, and we'll have an x is equal to negative 2. Now my guess is probably this positive value is the correct one, and this negative one is not. But we can check our work. Okay, base 2. And then let's go with the 8 first. So I'm plugging in 8 for x. Plus log base 2. And then we're going to do an 8 minus 6. Okay, this should equal 4. Oh, did I forget the parentheses again? Of course I did. Oh, I did that double set of parentheses. I don't know why I keep doing that. There we go. Yeah, it does equal 4. Now let's try the negative 2 to confirm that that one doesn't work. So negative 2. Oh, it's going to kick everything over, huh? Dang, okay. Negative 2. Oh, that one was fine. Negative 2 minus 6. And then, yeah, domain error, so that one doesn't work. Okay, so the answer is x is equal to 8. All right, one more time really quick. So I saw that I had logs that had the same base, and they were added together. So I took what was in the parentheses, and I multiplied them. From there, I knew that what I was solving for, x, was in the parentheses, so I rearranged this. I took the base, I brought it down. I have what was in the parentheses and what was on the other side of the equal sign, and I switched them. The answer, or what was on the other side of the equal sign, became the exponent, and then this went on the other side of the equal sign. I distributed the x, so x squared minus 6x, subtract 16 to the other side. Then I factored this and solved for x. I went with the positive one. I didn't choose the negative. Okay, reminder. When there's not a number down below for the base, it means it is a base 10. Okay? And these are subtracted. Oh, I wonder. I wonder if I should add that to the other side, because my first initial reaction is I want to do log of 3 divided by x, because they have the same base, and then this is going to equal log of x plus 2. Okay. Let me type it in really quick to make sure. Plus 2. Okay, yeah. So, because we had two logs, or they're the same base, they're both base 10, and they were subtracted, that's why we divided. So we did 3 divided by x, okay? So then it says, oh, they essentially cancel. That's interesting. It says if the logs are equal, or the same base, their arguments must be equal, meaning that because it's the log base here and it's the exact same thing on the other side, then essentially it's like the log cancels because it's on both sides of the equation. we have this 3 over x is equal to x plus 2. That, like, when it's the same log on both sides, then we can just say what is in the parentheses is equal to each other. Okay, that's nice. Okay, now we're going to get x out of the denominator. So we are going to multiply both sides by x. So it's like we're going to take this guy, and he's going to be multiplied by x. So multiplying both sides by x, because then it'll cancel right there. So we have 3 is equal to, and now let's distribute this x. So we'll have x squared, and then plus 2x. Okay. Similar to what we've been doing, how about we subtract 3? So we have 0 is equal to x squared plus 2x minus 3. Okay. It looks like something I can factor, so let's think about this. We need it to multiply to negative 3 and add, multiply to be negative 3, add to be a positive 2. So what about a 3 and a negative 1? Because these would multiply to be a negative 3 and they would add to be a positive 2. Okay, great. So now x plus 3, well, if you do x plus 3 equals 0, and then you subtract 3 to the other side, you have x is equal to negative 3, and we have x is equal to a positive 1. Now, if you're crunched for time, I would not go with the negative, I'd just go with the positive. But if you do have time, I really would check. And so we have our just regular log this time, 3 minus log, okay, I'm going to do the negative first. So negative 3 instead of x. And yeah, it's saying domain error, so that wouldn't work. And now let's try it with a 1 here. So this is just going to be a 1. Oh, natural log, oh no. Log of 3 minus log of x, and x is going to be a negative 3. Confirming, okay, yeah, it was a domain error. And then changing this to a 1. Okay, now that gives us some number. Now we're going to check, because that's what this side equals. And so then I'm going to check this side. Log of x, which is going to be 1, plus 2. Okay, so 3. Yeah, same value. So they equal each other. Okay, good. Again, pause the video, try this one, and then play the video, and let's see if we get the same answer. Okay, so I see logs, they're both base 10. It's a subtract. So we're going to do log 5 divided by x. Because they're subtracted, that's why we can divide what's in the parentheses. This is going to equal log x minus 4. Now when it's the same, when the two items on the opposite side of the equal sign are both log of the same base, then essentially the log cancels, or whatever is inside the parentheses, they are just equal to each other. Okay, great. So now let's get what we're solving for out of the denominator. So I'm going to multiply both sides by x. This x cancels, so we have 5 is equal to, now I'm going to distribute this. So I'm going to get an x squared minus 4x. Let's subtract the 5. So we'll have 0 is equal to x squared minus 4x minus 5. Okay, we need two values that multiply to negative 5 and add to negative 4. So if we do a -5 and a +1. They multiply to -5 and they add to -4. All right, great. And so this would mean we have x is equal to 5 and x is equal to -1. And then I bet it's the positive and not the negative. All right. The last couple. We did do 33 together, but I wanted to walk through it really quick just in case. So, the first thing, I noticed that there's a divide, and so it's kind of the opposite of what we were just looking at. Like, how about we do log of 7 minus log base 7. And I'm doing a subtract because it was a divide here. So then I'd put a 7 and then 36, okay? Now, remember we were talking about when the base and what's in the parentheses is the same, that it just equals 1. So this is going to turn into a 1. Bringing that minus sign down. 36. So I'm looking at these here. We have a 6, we have an 8, we have a 10. Now, 6 times by 6 is 36, right? Like this is log of 7, 6 times by 6. And when it's multiplied, that's the same as, I'm going to leave the 1 minus, okay, now, log of 7 plus log base 7. Because remember when they were multiplied, it's the same as adding them when the base is the same. And then they told us something right here. They said log base 7 of the value 6 is equal to a. All right, so then this becomes a, and this becomes a. So 1 minus a plus a, okay? A plus a, isn't that just 2a? So 1 minus 2a, I think that's the answer they're going after on this one. And then the last one. Okay. First thing, I'm going to play with this. I notice it's a divide. Let me start with that. So let's go log base a minus log base a. What was in the numerator was a c squared square root of d. Now, it's multiplied by the square root of d. Reminder that the square root is the same thing as being raised to the 1/2. So I am going to write it this way because I think it's going to be helpful here in just a little bit. So raised to the 1/2. And then the denominator was p5. Okay. Now, this is multiplied, so how about we take this and we break it apart where we're adding those values. I'm going to jump down a little bit lower. Ooh. Okay, no, I'm just going to write really small. So log a of c squared plus log d, or no, a, oh my goodness, log a of d raised to the 1/2 minus log a, yeah, we're doing good, log a of b to the 5th. Okay. Now, I have all of them broken apart. Let's deal with these powers, these exponential that we're raised to. Remember that we can take that power, that 2, and we can place it out front. So we can go 2 log of a c, just like that. So that 2 is now just out in front. And let's do the same thing. Since this is raised to the 1/2, let's put the 1/2 out in front. Log of a, and there's d. And then we'll minus it from, okay, this was raised to the 5th, so we'll put the 5 out front. Log of A per B. Okay. Right here it says log of base A of B is equal to -1. So we have that right here. Look right here. Log of A, log base A, B. So this would be a -1. Then look here, we have log of A, log base A of C, same as that guy. That becomes a 2. And then log of A of D, this guy right here, becomes a -3. Now don't drop these numbers we put out front. So this ends up being 2 times by 2 plus 1/2 times by -3 minus 5 times by a -1. Okay. Okay, double check my math, but I got 7.5. That's it.